course. Okay. So we are learning the transversal today. A transversal is a line that crosses two parallel lines. When we have a transversal that crosses two parallel lines, we can classify the angles in a transversal with a few different names. So first of all of the angles located inside of the parallel lines, so all of the angles in between these two parallel lines are considered interior angles. So 5 is an interior angle, 6 is an interior angle, 3 is an interior angle, and 4 is an interior angle. So we can write that over here. Now all of the angles that are located outside of the parallel lines, all of the angles up here, and all of the angles down here are exterior angles. And we can classify those as 7, 8, 1, and 2. Those are all exterior angles. So in addition to interior and exterior angles, we can then further classify those interior or exterior angles. So alternate angles are angles that fall one on one side of the transversal and one on the other side of the transversal. Those are called alternate angles. So we can either have alternate interior angles or alternate exterior angles. If we have two alternate angles and they're both inside of the parallel lines, such as this pair or this pair, we can classify them as alternate interior angles because they're both in the parallel lines, but they're on different sides of the transversal. Think about that. Alternate. Alternate means you're on the other side. You change. So alternate exterior angles now are angles that are both exterior angles, but they're on different sides of the transversal. So 1 is an alternate exterior angle of 8, and 2 is an alternate exterior angle of 7. So just like we have alternate angles, we also have consecutive angles. So look at the word consecutive. It has co as in the front. Co means together, right? So consecutive angles are going to be together on the same side of the transversal. So a consecutive interior angle is going to be an angle that is on the same side of the transversal as the other interior consecutive angle. So they're both together and they're both inside. And 4 and 6 could also be considered consecutive interior angle. They're both on the same side of the transversal, and they're both inside of the parallel lines. Just like we had consecutive interior angles, we can also have consecutive exterior angles. So consecutive means they're together, they're on the same side of the transversal, but this time they're both on the exterior. So 1 and 7 are consecutive exterior angles, and 2 and 8 are consecutive exterior angles. Another way that we can classify angles in the transversal is as corresponding angles. So again, we have the which means together. So these angles are going to be on the same side of the transversal, but one will be interior and one will be exterior. So angle 5 and angle 2 are an example of this. Angle 1, oh wait, they're on the same side. Hold on, let me just redo that. Okay, so angle 5 and angle 1 would be an example of that. Angle 6 and angle 2. Angle 7 and angle 3. And angle 8 and angle 4. Okay, so notice how when we classified angles as alternate exterior, consecutive, or corresponding, we were taking an angle from this group up here and an angle from this group down here and comparing them. But what if we want to compare angles that are in the same group? What if we want to compare angle 1 to angle 2 or angle 3 to angle 4? If we are comparing two angles from the same group, we can either classify them as vertical angles or a linear pair. So examples of vertical angles from the same group are 1 and 4 and 3 and 2. You know what vertical angles are. 1 and 4 or 3 and 2. Or we can classify angles from the same group as a linear pair. So these two angles form a line when added together. These two angles equal 180 when added together. These two angles equal 180 when added together. And these two angles equal 180 when added together. So we can do 1 and 2, 3 and 4, 1 and 3, or 2 and 4. Okay? So there is also an algebraic relationship between the angles in a transversal. If you take a look at the transversal, you'll see that the transversal creates two different types of lines. It either creates, let me get a different color, hold on. It either creates big angles or small angles. How do I know which angle is a big angle and which angle is a small angle? Well, I look at it. This is a much bigger opening than this. So therefore I know these are the small angles and these are the big angles. Now, the way that a transversal cuts through parallel lines, it creates the same measure for all of the small angles and all of the big angles. So in a transversal, all of the big angles are equal to one another and all of the small angles are equal to one another. Also, in a transversal, if you add a big angle to a small angle, you get 180 degrees. So therefore, if you wanted to find, let's say, the measure of this small angle over here, and all you know is the measure of this big angle over here, you could add them together and set them equal to 180 degrees. Now, I know a lot of you take screenshots of things in order to study for tests, so I think this would be a really great thing to take a screenshot of, so and you can use it to study for the test on transversals. So I'm going to leave this up for just a second, and if you want to take a picture of it, go ahead. All right, moving on. Transversal vocabulary. So I'm just going over the things that I explained in the previous slide, in this slide, okay? And this is just for the people that when they read text, they understand things better than pictures. So when we say interior angles, we mean inside of the parallel lines. So interior angles are all of these angles. When we say exterior angles, we mean angles outside of the parallel lines. So all of these angles and all of these angles. When we say different angles, or that the angles change, let's say this is the transversal. One angle is located on this side, and one angle is located on this side. That's what we mean when we say that the angles change. So there's basically three ways to classify angles in a transversal when you take one angle from this group and one angle from this group. And that is as an alternate angle, a consecutive angle, or a corresponding angle. You need to further classify these two types of angles into interior or exterior. If we're looking at angles from the same group, so let's say this is our transversal. If we're looking at angles just from the same group, we're not taking one from each group, we can classify them as vertical angles or linear pairs. So think about zeroing in on one group. It looks a lot like vertical angles, right? That's why we can classify them as vertical angles or a linear pair. Okay, so let's do a practice problem, right? So the first thing I want you to do when you see a transversal problem is to label all the angles as big or small. So this is a small angle, this is a big angle, this is a small angle. That's really messy, hold on. That's a small angle, this is a big angle, small angle, big angle. Okay, so I have labeled all of my angles. Now I can see that the question wants me to solve for x. Well, this is a big angle and this is a big angle. So according to my algebraic relationships, remember I have big equals big, small equals small, and big plus small equals 180. Which equation should I use? I think I'm going to use big equals big. So given that equation, I know that the measure of this big angle over here is 140, and the measure of this big angle over here is 9x minus 4. So I'm just going to do a simple solve equations, and I'm going to get x equals 16. Okay? Let's do one more quick problem. Two angles are alternate interior angles. Find the measure of each one of them if A is 15x plus 3 and B is 4x minus 108. Okay, so the question gives us some good info. We're going to have two angles and they're alternate interior angles. So what do we know about alternate interior angles? When you're drawing the figure, always start with a set of parallel lines crossed by a transversal. Now you can further add information. Two angles are alternate interior angles. So what do we know about alternate interior angles? Alternate means they're on two different sides of the transversal line, and interior means they're in the interior, so they're in between the parallel lines. Okay, so we can put one angle here, and we can put one angle here. Does this satisfy the condition? Yes, they are on alternate sides of the transversal, and yes, they are both interior angles. Okay, great, we're good to go. We have our figure. Now, let's label these angles with their appropriate amount that is given in the question. So A is 15x plus 3, and B is 4x minus 108. So what are our algebraic expressions? Big equals big, small equals small, and big plus small equals 180. Well, which one can we use to solve this one? Let's see. First, let's label all of our angles as big or small. This is a big, this is a small, this is a small, this is a big, this is a big, this is a small, this is a big, and this is a small. All right, well, A is a small, and B is a small. Small equals small. Let's use this equation. So 15x plus 3 equals the other small angle B, which is 4x minus 108. So I'm going to just solve this simple equation. Okay, so we just have a bit of an issue. I copied the numbers for A and B down incorrectly. So we are going to continue solving the question because it's not going to change our answer. It's just the answer that we get is not going to equal the answer that is in your packet. But I'm still solving it correctly and you can still see my work. So we're going to get 15x minus 4x gives us 11x. So we have 11x equals negative 111 divided by 11 divided by 11. X equals negative 111 over 11. Okay, so that is our measure of x. Let us find, I'm going to move this over here. The measure of angle A and the measure of angle B. So the measure of angle A is 15 negative 111 over 11. This is a ridiculous number. Okay, whatever. That's fine. Roll with the punches. Let me just grab my calculator. And we get 1,665 over 11 plus 3. Let's put 3 over 1. We get 1 and 11. We get 1,665 plus 33. You know what? I don't want to confuse you guys. Let's just go back and put in the right numbers, okay? These numbers are huge, and I don't think I'm really helping you by using huge numbers. I'm just going to change the question, okay? Okay, now I put the real and correct numbers in. Let's do it now. All right, so we'll draw our figure first. Always draw a set of parallel lines with a transversal cutting them. Okay? And we're looking for two angles that are alternate interior angles. Okay? So first let's label all of our angles as either big or small. Big, small, big, small, big, small, big, small. Okay, so we're looking for two angles that are alternate interior angles. So we know that they need to be in the interior, so they need to be in here, and they need to be alternate, so one on each side of the transversal. So let's do this A and this as B. Oh look, A and B are both small angles. So our equations that we can choose from are small equals small, big equals big, or small plus big equals 180. So I have two small angles. Let's use small equals small and set the two equations equal to one another. So A is 3x plus 4, and B is 4x minus 8. Now we just do a simple solving of the equation. And we get x equals 12. Okay, I'm going to put that over here. And then let's solve for angles A and B, because that is what the question asks us to do. Find the measure of each one of them. So angle A and angle B. Okay, angle A equals 3x plus 4. We know that x is 12, so 3 times 12 plus 4 gives us 36 plus 4 gives us 40. And then B is 4x minus 8. 4 times 12 minus 8. 4 times 12 is 48. Minus 8 is 40. And the measure of both angles is 40 degrees.